Good afternoon, students. Very basic method of for solving the linear programming problem, which is a graphical method, which is used only when linear programming problem has two variables. We can solve LPP with maximization objective as well as minimization objective. In this method, we have to draw the lines corresponding to the constraints, considering them as an equations. Then we see inequality in the line in the example, whether it is less than or greater than or equal to, and according to that we find a region of that corresponding constraint. Then we find the common feasible region and the point of intersections of that. Actually, point of intersection means the vertices of that common feasible region, because in graphical method, the optimal solution of linear programming problem lies at the corner points of the common feasible region. So let us see the examples. So consider this as an first example. Here, first example, maximization of Z, 5x1 plus 7x2, subject to these three constraints. X1 plus x2 is less than or equal to 4, 3x1 plus 8x2 is less than or equal to 24, 10x1 plus 7x2 is less than or equal to 35, and lastly, the positivity constraint is there. So as per the first step, we will consider all these constraints as an equations. So what we'll do, we neglect all the inequalities in these constraints and then consider them as an equations. Simultaneously, we will write them in the intercept form. You can see the first constraint is x1 plus x2 is less than or equal to 4. Neglecting inequality, that will be an equation, and it is x1 plus x2 is equals to 4, and in the intercept form we can write it as x1 upon 4 plus x2 upon 4 is equals to 1. It means that this line intersects x-axis at the point 4, 0 and y-axis at the point 0, 4. So immediately we can draw that line. Just plot these 2 points on that graph and draw the line. We will get that line. Then second constraint is 3x1 plus 8x2 is less than or equal to 24. So if we consider this as an equation, then it is equals to 24, and in the intercept form we can write it in this way, that x1 upon 8 plus x2 upon 3 is equals to 1. Next, same way, 10x1 plus 7x2 is equals to 35, and in the intercept form it is x1 upon 3.5 plus x2 upon 5 is equals to 1. Now I think you don't have any problem to convert the equation of a line in the intercept form. So it is very easy actually. If we convert it in the intercept form, instead of getting the points on the line, immediately we can draw that intercept, plot that intercept and draw the line. Then these are the positivity constants. Again, I have neglected the inequality here and I have written equal to 0. So when I write x1, x2 is equals to 0, then it must be in the first quadrant. Okay. So now we will solve this with the help of GeoGebra, this software. Now here directly I will draw the line, because we have seen how to draw the line, how to find already we have the points, then we can plot it on this 2-dimensional system, and then using the scale we can, using the scale, we can write it, draw that lines. Compulsory use the scale to draw the lines, otherwise it will be wrong. Okay, so let me write directly the first line. Also, we have seen how to find the feasible region using that origin test. Okay, so first equation is x plus y is less than or equal to 4. X plus y is less than or equal to 4. So here the line is there, and you can see the intercept also. Here this point 4, this is 0, 4, and here is the point 4, 0. So these are the intercept. Again, I can show you in this. Here intercept, x intercept is 4, y intercept is 4. So we can plot this here, these 2 points, and we can join this. And now what is the original inequality in this? It is less than or equal to, and 0, 0 is satisfying this LHS, that is 0 is less than or equal to 4. So your feasible region of this line is towards origin. Okay, let us go to the second example. It is second constraint, which is 3x1 plus 8x2 is equals to 24, and the inequality sign is less than or equal to. So let us draw this. 3x plus 8y is less than or equal to 24. So automatically here the line, we have drawn the line here. A is the first line, B is the second line. The intercept are, look at here, 8, 0, and here it is 3, 0, 3. Y intercept is 3 and x intercept is 8. So it is sufficient to find that intercept. The next line is 10x1 plus 7x2 equal to 35, and the inequality is less than or equal to. So let us draw this. 10x plus 7y is less than or equal to 35. Yes. Okay. So now here, if you observe, now I will not draw that x is greater than 0 and y is greater than 0. So obviously this region, which you can see dark region, is the common feasible region. Let me show the points here. I will show the points. This is first point A, then this is second point B, then this is third point C. I am plotting the points of the common feasible region. Then this is the next point. So I will not plot here the origin. Origin is considered, and then here you can say A, B, C, D, and E. This is the common feasible region for this LPP. Now what we have to do, as soon as we got this common feasible region, we have to check out its vertices. So now there are 5 vertices along with this origin here. Okay, so let's try. Okay, along with this origin. So we know coordinates of E, which is 0, 0. Then coordinates of point A also we can immediately find, because here it is 0, 3. At 3 it is placed here. Then coordinate of this point D also we can find, because this is one of the intercept of this line C, and I think it is 3.5. So 3.5, 0. Now these 2 points, we don't know coordinates of these 2 points B and C. But we can find here, we can check here that B is the point of intersection of first line A and B. Here, this first line A and B. And C is the point of intersection of first line A. Look at here, this is A and this line is C. And we know that point of intersection of 2 lines can be obtained by solving them simultaneously. So let us do that. So now as soon as we get this feasible region, we will proceed further to find all the vertices, coordinates of all these vertices. So let us go. So Among of these 5 vertices, we have to calculate only 2, B and C. Then let us see how we can calculate it. So, okay. So if you observe this point C is the, yes, point C is what? Intersection point of 1 and 3. I will show you here. Intersection point of 1 and 3. A means 1 and C means 3. Okay. So consider these 2 equations 1 and 3 simultaneously. Then solve them. Now you know how to solve it. So multiplying this 7, you can see this calculations here. Multiply equation 1 by 7 and equation 2 by -1 as we have to add them. So here x2 will get cancelled and here it is -3x1 equal to -7. So x1 equal to 7 by 3. Substituting value of x1 in any equation, we will find value of x2. So therefore, what are the coordinates of point C? Coordinates of point C is 7 upon 3 and 5 upon 3. Okay, so we got one coordinate. Then next we will go to this point B. So actually here it should be B. Then B point is here point of intersection of line 1 and 2, right? Don't see this vertices. This is B point actually. I can change it, no problem. This point we are considering as B. Okay. So multiply equation 1 by 3 and equation 2 by -1. Solving it here, you will get x1, x2 is 12.5 and x1 is 8 upon 5. Therefore, the coordinates of this vertex B here are 8 upon 5 and 12 upon 5. Right. So we calculated for C as well as now we calculated for B. What we considered from the graph, we have checked that B is point of intersection of line 1 and 2. We consider the corresponding equations, solved them simultaneously and got the point of intersection here as B. Then also for C, C is point of intersection of the line A and C, that is 1 and 3. Then we consider these 2 equations and solve them simultaneously to get the coordinates of point C. So now we have all coordinates here, coordinates of A, B, C, D and E. Okay. So let us go to the next part of this. Now we collect all these points and we will make a table. Yes. So this way. So here, let me change this. This point is our B. Only there is change in this point B and D. And this was our point D. Okay. So A, here let me write this as O. And this is my A. So actually here this is point E. This is point D. This is point C. This is point B. And this is my point A. From the graph, you can check it here. Look, A, 0, 3, B, point of intersection here that we change now. D is actually 3.50 and E is the origin. Okay. Now make this type of table. What is our Z? Z is 5x1 plus 7x2. Then what we have to do? We have to find value of Z at every point. These are all corner points or you can say vertices of the common feasible region of the given LPP. Then you just find value of Z at these points. So obviously at origin, x1 equal to 0, x2 equal to 0, so value is 0. Then D, vertices of D is 3.50 and the answer is here 17.5. For C, coordinates of C are, let me show you that coordinates of C. Here this was B and this was C. 7 upon 3, 5 upon 3. B, 8 upon 5, 12 upon 5. Look, 7 upon 3, 5 upon 3. And substitute in Z, we will get 70 upon 3, which is nearly equal to 23.3. Then this point is B, 8 upon 5, 12 upon 5. And if you calculate value of Z, then it is 124 upon 5, which is nearly equal to 24.8. Exactly, it is equal to 24.8 now here. Here you can say nearly equal to. And last point is A, which is 0.3, and the value is 21. Now our objective function is of maximization. Now here you have to check the type of objective function. What is the type of objective function? Maximization. So among all these values, you have to select the maximum value. So where you see the maximum value, obviously here is the maximum value, which is 24.8. And therefore, this is our Z max. Look at here, this is our Z max. And the corresponding values of X1 and X2 are values are the decision variables here. So here you may, when you solve this linear programming problem by graphical method or simplex method, this is one of the drawback that when we assume the decision variables, generally this is number of units to be produced, number of things it is, number of things, and number of things cannot be in fraction. So to overcome this, means in graphical method also and in simplex method also, we get this values of decision variables in the form of fractions. To overcome this disadvantage, this problem, integer programming problem was then introduced, which gives me purely integer values of x1 and x2. But we are not going in that integer programming technique. Here, whatever it may be, we are getting the values that are our values of decision variables we will consider here. So hence, finally, we can write down that the optimal solution is x1 upon 8 upon 5, x2 equal to 12 upon 5, and value of Z max is 124 upon 5. So again, you check this diagram. So from this, the importance of this graph is only to detect out the common feasible region, which is actually the important part of this example. Because if you cannot find a common feasible region, you will not get the vertices, and if you will not get the vertices, how to find the coordinates of it and how to check the values. So the important thing is to draw the graph and find out, identify the common feasible region and properly calculate the coordinates of the corner points, which is very important part. So here, as there are 5 points we have got here, and then same 5 points we have put it in this table by calculating the coordinates of C and B and checking values of Z here and identifying the maximum value. So this is the one type of example in which your objective function is maximization. You are getting here the bounded region of this example, bounded region of this example. And the solution of the example.